Hello, my name is Abhi. Thanks for attending. I am currently working as a data scientist at WATTPAD, which is an online content publishing and a social media platform. It has a large collection of fictional stories and novels if someone wants to check it out. Based on my experience and knowledge of utilizing LLMs in different commercial applications throughout my career, today I will be discussing about the challenges of using LLMs in production environments and effective solutions. So let's begin. So McKinsey's research suggests that LLMs and generative AI could add roughly $4.4 trillion to global economy, potentially exceeding 12 trillion when factoring in increased worker productivity. However, despite the economic promise, a recent KPMG survey suggests that US executives revealed that 90% of them have significant concerns about LLM risks. And these risks primarily include cost, security, and safety. So let's explore these risks and examine some examples. Here are some examples of things going wrong due to inefficient integrations of LLMs into a production or a user-facing setting. The promotional demo of Google's chatbot Bard, which was posed as an alternative to ChatGPT, showed the bot fabricating information, resulting in a huge financial and reputational loss for Google and its parent company, Alphabet. On the other hand, several customers complained that Microsoft integration of ChatGPT in Bing as responses generated by it were toxic and inappropriate. There are, I guess, millions, not millions, but like a couple of pages in Reddit of how bizarre the responses of Bing were in some of the chats that the users having read it. These examples might be focused on specific applications of LLMs like chatbot, but later in the presentation, we'll see challenges for other applications as well. So far, we just learned that LLMs have potential for big economic impact, but there's an undercurrent about concerns like security and cost associated with them. And if LLMs are not efficiently integrated in production application, they can do more harm than good to brand and the bottom line. But dealing with these issues should be straightforward, right? Actually not. In the same survey by KPMG, it was found that less than 10% of LLM prototypes make it to production, mainly due to uncertainties on how to mitigate these risks. For example, Bloomberg spent a lots of money building their proprietary LLM, and it's still primarily being used by researchers internally to avoid any incidents similar to what we saw in the previous slides. So then how should one move from prototype to production? Well, this is exactly what we'll be going to talk about today. But before moving on, I think it's important to clarify what do I mean by production environment, as it could be different things for different people and different companies. From my point of view, a production application has two main characteristics. One, it has a direct or indirect impact on a user. Like we see how chatbot responses going toxic can directly impact a user's preference, a user's behavior, a user's interaction with the app. Or let's say if you are using LLMs for QA, summarization, and you are making decisions based on the answers that you're getting from LLMs, they could be biased, they could be false, they could be hallucinating, and then they could have an adverse impact on your business. The second factor is scale. So when I talk about production, I expect some level of requests, maybe in a couple of thousands daily requests, because some problems that I'm going to talk about are only pronounced when you have at least 1,000 daily requests or so in your application. So moving on, since these companies want more transparency and control, they are more leaning towards an open source solution. Having said that, I want to mention that there is no right solution for every problem. People often forget that LLMs are just a part of a larger application or pipelines, and they have other aspects as well. So application can have a vector database, it can have a monitoring system, a front end, or there are other requirements within the application as well that influences your decision on which LLM should you be choosing, like a commercial one or an open source solution. Since open source solutions are a preferred choice, we'll be focusing on them for the rest of the session. Even though they offer some benefits, they have their own issues, like fine-tuning and hosting them can be challenging from a cost perspective. Also, often you are responsible for aligning them to make sure that they don't produce any unwanted or unacceptable responses, as most of the times open source models are not very well aligned as much as their commercial counterparts. Training a model with billions of parameters from scratch is unrealistic for most of the companies due to the demanding nature of the task. And this leads to our first challenge, which is cost. As usually the cost of training a model from scratch could be in hundreds of thousands to $1 million to train and infer from these models. So more often than not, companies rely on fine-tuning commercial or open source LLMs. But as we briefly discussed in the last slide, fine-tuning and hosting open source LLM can be very costly as well. Approximately 90% of the lifetime cost of using LLM can be accounted to just fine-tuning and the inference cost. And again, I'm talking about open source solutions. So let's talk about ways on how we can optimize these steps. First, it is important to identify the right fine-tuning technique for your tasks. From different options that you can see in the image, there are some general guidelines that I would like to share. First, for tasks that are very complex or are new to the base model that is not related to something that a model was trained on, fine-tuning might be the right choice. Full fine-tuning might be the right choice. But this can also lead to catastrophic forgetting, which is a stage where after fully fine-tuning the model may start to perform poor on some tasks that it was really good at before, but then it was not trained on those tasks during the fine-tuning, and then it performs poorly on those tasks after this stage. So if you are fine with that, or if your goal is to just fine-tune a model for a very specific task, then full fine-tuning on very complex tasks can be really beneficial. Second, for PEFT methods, prompt modifications are the least cost-intensive and offer a really good starting point for simple tasks. Third, LoRa is the most commonly used method and has the best cost to performance ratio amongst other options. And last, adapter tuning requires a deep understanding of the architecture, but usually provides more granular control over the fine-tuning process when compared to other approaches, but generally leading to comparable performance to LoRa. Once you have identified the fine-tuning method, picking the right hardware and the framework for the process can have a significant impact on the cost and time. In this figure, we see the time it takes to perform PEFT on a 7 billion parameter Llama 2 model with different EC2 instances on AWS and different configuration within those EC2 instances, like if the instance has if the model is quantized or not, or if the model is using FSDP, which is like fully sharded data parallel, a distributed training framework from PyTorch. So let's look at some of these insights. First one is newer generation GPUs are better. You can see it takes around 166 minutes to fine-tune the model on a G4DN 12x large versus only 57 minutes on a G5 12x large with the same configuration. Next, if the model fits on your device memory, vertical scaling might not make that big of a difference. Again, G5.2x large takes 43 minutes versus G5.4x large takes 39 minutes. Pretty close. Next, horizontal scaling using FSDP or anything else like a deep speed almost always outperform vertical scaling and quantization. Here we can see that in a G5.12x large, using quantization, it takes 57 minutes versus G5.12x large enabled FSDP, it takes 26 minutes, which is less than half of the time. Interestingly, if you compare all of them, then the most cost-effective is the G5 2x large, showing that the quickest model might not always be the most cost-effective. Once we have identified the hardware, we can then further optimize the performance for inference and fine-tuning by applying hardware-specific frameworks, like shown in this image, where we can see that the inference speed almost doubled from 4x to 8x on the same H100 instance by just applying the NVIDIA TensorRT framework. And there are different frameworks that you can choose from. Depending on the framework or the format you choose, you gain different benefits. So general frameworks like PyTorch and TensorFlow can be used for both inference and training. Whereas if you go for inference specific frameworks, you lose some compatibility, but you gain some speed. And finally, there are device specific framework like OpenVINO for Intel, TensorRT for NVIDIA, and CoreML for Apple hardware, providing the highest level of optimization. Finally, on the top of all of this, you can further optimize the model by applying different optimizations like quantization and continuous batching. You can either do it yourself or you can use the managed open source solution. In this figure, we see that the baseline Hugging Face model inference speed and compare it with the model that is optimized. And we can see that the difference is approximately 10x when compared between a Hugging Face model versus a VLLM, which is a library that provides all these different optimizations like KV, cache memory management, optimized transformer code, etc., etc. So to sum it all up, as we saw in the fine-tuning slide, optimal hardware may not be what you always think about in the first glance. Also, there are multiple GPU providers like NVIDIA, Habana, etc., that offer similar performance on lots of the tasks, but sometimes can have a huge price difference. So if you go for Habana Gaudi instances, they're often cheaper than state-of-the-art NVIDIA and H100 and can perform comparably on some of the computer vision and NLP tasks. Next, we can further optimize LLM fine-tuning and inference using techniques like quantization, distributed training, and we can use libraries and frameworks like Llama CPP if you just have CPU, GPTQ if you just have a single GPU, and Accelerate Deep Speed or FSDP if you have multiple GPUs, and so on. Lastly, if our goal is peak performance, latency, or throughput, and it's very crucial for us, we can further optimize these models using hardware-specific frameworks, like we discussed about TensorRT or OpenVINO. And a really good library for this is Hugging Face Optimum library, which is open source and provides you with different optimization frameworks that you can use to make your inference and fine-tuning much faster. But if you want to use and go ahead with a managed solution, Ray's and AnyScale Ray LLM library or Mosaic ML's inference library and Hugging Face TGI library are very good options to get started. The second challenge that I want to discuss about is security and regulation. I referred in one of my previous slides that LLMs are often just part of the application, and like any other component of the application, it's crucial to ensure that LLMs are integrated with security and regulation in mind. There have been many incidents where companies have been attacked, often resulting in leaked data, confidential information by leveraging vulnerabilities of LLMs. Let's look at some examples. Countries in Europe banned OpenAI services for a brief period of time due to data privacy issues. Sensitive data from conversations with ChatGPT got leaked multiple times, revealing key information from Samsung's R&D division, making them ban use of OpenAI and any other tool within the company. And the same thing was also advised for Amazon employees and many other companies. There are many copyright claims on companies owning these commercial LLMs for using proprietary work or proprietary data for training their model without proper consent. And hackers are finding more and more ways on how to attack these models, and it is important to understand these threats in a bit more detail. So let's start with the manipulation of input and output. Attackers can create input that leads to undetected manipulations, which can be both direct and indirect. Let's say an attacker creates and modifies a public website like a GitHub repository and adds a malware along with other code. And if I use an LLM to fetch that data and that LLM is integrated with a code execution environment, that malware can get to my code execution environment and compromise my application by either leaking the user data or hampering the functioning of the application. Also, LLMs have been shown to memorize information passed to them not only in training, but also in prompts. And that can end up including that information in responses. So it is necessary to check the output for any PII data or any unwanted things like unsafe content, malicious code, etc. Next, it's about inefficient integration. When LLMs interface with other systems, uh, unrestricted agency may lead to undesirable operations and actions. And this is an example of the next problem with LLMs is the DOS attack. So in denial of service or DOS attack, an attacker interacts with an LLM in a way that is particularly resource consuming, causing quality of service to degrade for them and others. A lightweight example is something when you ask a chatbot on a popular travel booking website to solve a complex math problem or ask who their CEO is, as I'm showing in this particular example. Such conversations don't add any business value to the product, but drain their compute and cost resources. Third is plugins connecting LLMs to external resources can be exploited if they accept free-form text inputs, enabling malicious requests that could lead to undesired behavior or remote code executions. For example, an attacker can send an email to someone that uses LLM-powered application to manage their email. An attacker can easily wrap an attack prompt in a genuine-looking email, and the attack could be, let's say, fetching all the email address of the recipient and sending the mail to all those found in the recipient's email address book. And this prompt could be as simple. This is the image which describes the attack, and this could be as simple as this prompt as shown in the image. Moving on, so this is the final types of issues in the security section for LLMs. So lastly, due to the data being fed to train these LLMs, there can be multiple issues like copyright infringement, or even they can be used for future attacks. For example, an adversary can insert few poison samples in subset of training tasks shown at the top of the figure. These poison examples contain specific trigger phrases. For example, James Bond, and these consist of carefully constructed inputs and output label. And at test time, an LM trained on this poison data will produce frequent misclassifications or degenerate outputs. And whenever it sees that trigger phrase, or even for held out tasks that were not poisoned during the training time. And this could again impact directly or indirectly the business decisions or the responses that the users see in real time. So what are solutions for some of these things? As with any other production application, security should be the priority when designing the application. Companies should create security policy around the use, development, and productionization of LLMs and other Gen AI tools to prevent incidents like Samsung and OpenAI's data leakage. Some general guidelines that NVIDIA suggested in their NEMO framework are: do not disclose all the details of services and tools available to LLMs to avoid issues like over-reliance and insecure plugging if responses from APIs is not what you're expecting it to be. Make sure there is some check-in mechanism in place to separate users from bots trying to do denial of service attack. Also, it is better to log interactions whenever possible to identify possible attacks and get data for future improvements for things like adversarial testing or RLHF. For applications making mission-critical decisions, making sure that a human goes through a sample, if not all, of the outputs is also important. Next, there are different tools that we can use to resolve some of these issues. For instance, to make sure that LLMs is secure, the output from LLMs are secure, safe, and the LLMs don't engage with users in conversations beyond what it is expected to do. We can use a library from NVIDIA, which is an open source library called NEMO Guardrails, which allow you to define conversational flows, security, and safety guidelines that LLMs will follow throughout all its conversation. Here you see a Golang file which provides examples of what an off-topic input will look like. And below that, the developer has defined a flow about what to do when the input is off-topic. Here we provide users with response, what can't go off-topic, which is defined in the next section. Also, the input doesn't have to be an exact match as a trigger to trigger the flow, as it uses semantic matching on the backend. And this is an example of the topical conversational or topical guardrail that NVIDIA through their library provides. But there are other guardrails like safety and security, which are similar in the concept, which we can use to make sure that the responses that we are getting are safe and secure. On the other hand, there are tools like private AI and other cloud-specific services on AWS and other cloud service providers that we can use to make sure that there is no unwanted, sensitive, confidential, or PII information in the generated response to prevent data leakage. Tools like Deep Checks and Arthur allows for model evaluation for detecting issues like training data poisoning. Lastly, model cards of LLMs should be used to should be inspected to check for any known issues and vulnerabilities. LLMs, without proper fine-tuning and alignment, also pose safety, toxicity, and biases and misinformation. And this is where our third challenge comes in, which is trust, safety, and biases. But you may ask, why should we care? Producing false facts, often called hallucination or biased or unsafe content, can lead to bad business decisions and impact brand image, and can even have criminal proceedings, as we have seen in previous examples, depending on the cases. But why these models have these issues? There can be multiple reasons, but the most common is low quality data. As the adoption of LLMs increase, companies are in a race to develop better and better models. And one of the things to improve the model is to have more data, which is directly related to the increasing number of training tokens meant to improve the performance, which often comes at the cost of data quality. A survey from Washington Post revealed that the C4 dataset, which is used to train popular models like T5, contains large amount of harmful content, including swastikas, white supremacist, anti-trans content, etc. And if there is no proper filtering done, this could be these biases and these issues can very well move in the model that's trained using that data set. So what is bias? The majority of academic work on machine bias fails to engage critically with what constitutes a bias in the first place. There are two categories: performance disparities and social biases. Biases are often use case specific. Apart from common biases like gender, race, as you see in this image, there could be other types of biases. So for example, let's say that you are a consumer electronics store, and you might want to know if your bot is neutral to products, different types of products. So I was trying to see if different chatbots, commercial ones, are biased towards any particular type of commercial or consumer electronic. And I found that different bots are aligned or biased towards different types of consumer brands. Some bots said that Apple is better, and some said that Android is better. And these were done as these were done in multiple attempts to ensure that there was no element of randomization. And similarly, there was another research paper that found that different chatbots have different political alignments, where some bots favored liberal, whereas other bots maybe favored more conservative side of the political view. And then these biases can very well lead on to the decision making of these through these LLMs, be it through summarization, be it through question answering, etc. Second is, what is toxicity? So generation of rude, disrespectful, unreasonable text that would make someone want to leave the conversation. And again, toxicity, like biases, is subjective to individual and the company. And the last problem with the trust and safety is LLMs are often blamed for generating false information or misinformation. But there's also disinformation. So misinformation is when the LLMs unintentionally produce false facts, like we've seen examples from Google, Bard producing some wrong facts about James Webb Telescope. But then LLMs can also be used to spread propaganda or disinformation with proper intention to make harm to a specific community or someone. And one example is, let's say LLMs can be used to generate false articles about relations between vaccine and autism. An example of misinformation is like what we saw with Google's example, where it said that James Webb Telescope discovered something which it didn't. So what are some solutions for trust and biases, for trust, safety, and biases? So the first one is we need to understand what are use cases. And first and foremost, we need to define what's problematic for us, like iPhone or Android or male versus female, and if and how the users can be exposed to these biases either directly or indirectly. Next, after defining what content you would not want the user to see and what biases your system should have or should not have, you should try and evaluate the current level of biases and safety of the system. Some tools that I would like to suggest that we can use here is Hugging Face Evaluate Library. It's a library for anyone to evaluate machine learning models and datasets. It provides access to different datasets, benchmarks, and tools that are commonly used to evaluate things like biases, safety issues. For example, Truthful QA for hallucination, Bold dataset for biases, Toxygen for safety. Next one is disaggregators. This library allows you to easily add new features to your dataset to enable disaggregated data exploration. Basically, it helps you in identifying biases and issues related to biases and other issues related to biases in your dataset. You can also use other managed services like deep checks or specific tools for specific tasks, as you can see in the image below. For example, Perspective AI is a really good open source tool from Google, which can be used to detect the toxicity of the generated responses from the model. Also, I would like to emphasize again that it's important to read the data set and the model cards or research papers about the model and the data set that you're trying to use, and make sure that they are that the thing that they want to use them for, they are intended for that. For example, Llama 2 specifically mentions that they on their base model and as well as their supervised fine-tuned model, they are not meant for generating content that is non-English, because they were not trained on, or they were like trained on very less non-English data. But I've seen multiple attempts of people trying to use them to generate non-English content and then saying, okay, these models are not producing very good content. But then you'll probably have to do some fine-tuning or try other approaches, and you can't just take them on face value, because these things are clearly mentioned on their data cards and on their model cards as well. So what are some of the solutions? So once you have identified these issues, evaluated these issues, how you can reduce them? So you can use techniques like RLHF, constitutional AI, and then you can fine-tune your model. So let's say that model is not biased towards specific section or not producing unsafe responses. The figure below shows an animation of the results of the harmfulness and helpfulness evaluation of the Llama 2 models throughout different stages of RLHF and supervised fine-tuning. There seems to be a clear correlation between the incremental stages of RLHF and the model being more aligned based on the criteria that was set by Meta. But we can also do very similar steps to make sure that the model is aligned to whatever we think is our preference. Even with using these techniques, there are chances that your model may sometimes produce unwanted responses. And here we should apply our learnings from the security section to monitor and parse the output to first check for safety, security, before showing it to the end user. Lastly, we use specialized models to avoid biases and hallucination, like Korean language. Like for Korean language, Naver's HyperCLOA model performs better than the GPT ones. Similarly, we can use domain-specific models whenever available, like Bloomberg GPT and Alpaca for finance and medical domain respectively. So I know it might be a lot of information to consume, and in case someone or some of you might get lost somewhere, here are some key points that I would like to leave you with. First, LLMs might add additional value to your product, but risks like cost, security, and safety might be a blocker for using them in production. Start by identifying best use cases and carefully define the scope and the authority of LLM in your application. Utilize compute-efficient hardwares, frameworks to minimize inference, fine-tuning, and other costs for open-source LLMs. Define security guidelines, integrate tools like Nemo guardrails and other PII tools, PII scrubbing tools in your applications for secure usage of LLMs. Define, identify, and measure relevant trust and safety risks in your model using different libraries that I just mentioned and data for your use case. develop processes and tools to mitigate these and monitor them as you generate more and more responses from these models in production.